now on to fractions. Yay! Even though our stuff was, I think, way more worthwhile to talk about, because sometimes it just helps too. That's life, man. All right. So check out this lovely week here, you guys. It is good to vent. It's important to vent. Look at that. 2 assignments this week. Just 2. And Junior, this is on my mind because I was looking at your to-do list. There's like one thing I have to take off of there that you don't have to do just because of when you joined. So I'm going to do that. I'm going to make a note. Oh, and I'm going to also write down that Aiden, Isaiah, and Vivi, you guys all showed me your planners. Junior dashboard. Okay, and then Lily. Oh, you did. Yes, Sarah, you sent it to me. That's right. Sarah's good. I was meaning, oh, that's okay. That's fine. If you let, well, excuse me. Nice. Yeah, I did too, but you guys can't tell because, and a while ago. Nice. My son needs a haircut, but I can't take him in to get a haircut because last time he got a haircut, he punched the stylist. So yeah, he's got sensory processing disorder. So like when you cut his hair, it all feels just weird. He hold on. First he punched the stylist, then he threw up right on her chest. Yeah, that was. I never went back there. No. Yeah, that's pretty gross. I know. Oh my gosh, yeah, Isaiah, that's my child. Sometimes when you see it, you're like, whoa. Oh man, I tell you. Okay, so and then Lily, if your dashboard is still a little bit off, just let me know and I will adjust. I think I did. I'm gonna make a note just to double check it. But I'm still gonna do that. But like, remember, if you're in the red, send me that email. I want to know what your plan is, or I don't have a plan. I need help here. Whatever. I just want to see you taking that step to communicate with me. But yeah. If you don't, I'm gonna call you. I have to say that, but I will. I seriously will be doing it. So. All right, so today we're going to be talking about just comparing fractions and getting that common denominator. So, yeah, there you go. That helps sometimes. My daughter parents me. Sometimes she'll say she's the mom and I'm the honey. That's the name for the daughter. She'll be like, "You're the mom," or "I'm the mom and you're the honey." So, yeah. It sounds kind of weird, but I make the banana bread in the house. Aiden, that's the best. I love that. Okay, so you guys know about fractions, right? We know that they are parts of a whole. So in your assignment, you're going to have questions related to create a fraction to represent the picture. Okay, so fraction, like, and this stems to when we do with ratios and all of this stuff. And I know you guys have seen fractions before, but it's good to review because it's all parts out of a whole. So when you guys are dealing with ratios or percentages, part over whole. Oh my gosh, Tom, I couldn't handle the anxiety with Tamagotchis. Could not. I would always kill my pet. And I have 2 children and a cat, so yeah. Too much anxiety, too much. So parts out of a whole. So in this cup, there are 2, this cup, measuring cup holds 2 parts, right? 2 parts. The whole is 1 whole cup. Yeah, it is, Sam. You have to keep a pet alive and you have to feed them and all of this stuff, and it's just so much anxiety. Oh my gosh. So Do these pictures make sense, you guys? Big thing with fractions is I want you to think of it as part over whole. That's right. I am. I think that's why I like Pokemon Go. Right. So part over whole. You guys got that with fractions? Yay. Yay, fractions. I got some cool EVs. Those are neat. Okay. So again, fractions are part over whole. Oh, Taylor, you can show me right now. Yeah, that's totally fine. Perfect. Let's see. Oh, I see it. Very good. You are good to go, my friend. Thank you, thank you. Perfect. All right. Okay, so again, with the fractions being part over whole, okay, look at those examples there. What do you guys think would be a good fraction to represent? Oh, wait. Oh no. What do you guys think would be a good fraction to represent that first part there? That's like a dosing syringe, like when you give a toddler or a baby some medicine. What would be a fraction that would represent that? Aiden says 3 out of 10. Do you guys agree? 3 out of 10? CC, yes. What do you guys think? Taylor, Lily, Junior, do you guys agree with the 3 out of 10? Cool. Why do you guys think it's 3 out of 10?
Because there's 10 parts, but there's 3 shaded parts. So
Yeah.
it's like, yeah. 3.
Totally right. Very good. 10 is the whole. Yep. Perfect. I love how you guys are putting it in different ways. You're exactly right. What would the fraction be for the bottom one there? Yep. Yeah. Very good. Good. There's 3 equal parts and 1 shaded part. Very good. Nicely done. Okay, who could draw a figure and then shade the part of it? So let's pick someone who's going to draw. Isaiah, can you draw a figure that has 6 equal parts? Isaiah's going to impress us here.
5 out of 6?
Right, yeah. Yeah, and you could do the whole thing. That would be good. So we want to draw 5 parts out of 6 of a figure.
So
there's quite a few ways that you can do it.
These are looking very equal.
But we know it's hard to do on a figure like this. We're assuming equality, right? I think we could do that.
No.
Oh, look at that.
It's pizza.
Very good. Very, very good. I got a lot of them showing up. Keep going, guys. Do we have to use circles? There you go. I like what I'm seeing. Yeah, good. Good. And Isaiah, we would, even though you have 5, no, that's perfect because you have 5 out of like 6 that would be there. Yeah, that's good. Good stuff. We would just want 5 represented. So the one on the right side of the screen that has yeah, we would want to take one out. Bam, 5 out of 6. Nice. No, you guys are perfect. This is good. We would draw a figure showing 6 whole parts and only shade in 5. And you see Isaiah, he did not shade in 5, but he only has 5 there, and it's implied that there'd be a 6th piece there. The 2 that works. Good. Bar graph. Good job. Okay. Question here. You're also going to see some real life stuff, even though I suppose it's not terribly real life, like to your real life right now, dealing with planets, but it's still in our lifetime. Of the 8 planets, I know, in our solar system, this might be from, oh, good, Aiden, very good. This might be old because last I heard, I thought Pluto was back to being a planet again. I'm not sure. I know it was
Rick and
gone.
Morty influenced it.
Say it again.
I think Rick and Morty influenced it.
Really?
No.
No, I'm just kidding.
I heard that there's like a state that still thinks that Pluto is a planet.
Okay.
Yeah,
Sam is huge.
I started getting interested in astronomy when that was announced.
Yeah.
But literally like 2 days later it was proven wrong again. So
I believe
they're like,
that.
"Are you sure it's not a planet?" They're like, "Yeah, we're sure."
I like that. Okay, so we'll go with it as being accurate. So of the
Pluto
8
is
planets,
just a way for scientists to get recognized. Like, oh, I actually think it is a planet because of this, and then they get proved wrong.
it's a dwarf. Oh, look it. They're calling it a dwarf planet. So maybe that is the most accurate.
Mm-hmm. It's like
more of the size of
kind of a planet
a big
because
moon.
it keeps coming in and out of like the big chain reaction of the planets going around and stuff.
Very
like
cool.
It still circles the sun, but it's not really a part of our solar system, I guess. Yeah, it's a dog.
A dog.
It's a dog from Mickey Mouse.
Oh, Isaiah. Okay.
Oh, yeah.
That
I think
makes
that might be
sense. That does make sense. We should.
No, I think it's because it was originally a meteor. It was just a very, very big one, but it was like, oh, why don't I just join your orbit?
I like that. Maybe I should be a planet today. Okay, so why
I want to be a planet.
Why is Pluto? Oh, I like that. What just popped up? Why is Fortnite not working? Nope,
Of
that's not one.
course.
Why is Pluto
Fortnite not working?
Okay, downgraded the status because it did not meet the 3 criteria the International Astronomical Union uses to define a full-size planet. Essentially, Pluto meets all the criteria except one. It has not cleared its neighborhood region of other objects.
I don't want to be a planet anymore.
Sam, that's hilarious.
Honestly, I feel like
done.
the only way we can get rid of Pluto is if a meteor crashes into it. We just nudge it out of the solar system.
Oh, that's funny. I don't want to be a planet anymore. It runs into the sun. You guys are funny. Okay, so there are...
Pluto is that hyperactive child that can't focus on something for like 5 seconds.
Right, that's our ADHD planet. That's okay.
Yep.
We understand, Pluto. We get you.
Don't worry, Pluto. You're okay.
Oh, yeah, I wonder. No.
Maybe. Or maybe it'll crash into it and give it a moon or something. Pluto, I'm gonna end Earth's career.
Pluto's sick of taking all of our grief.
Great. Conspiracy theory. Pluto's gonna take over the Earth. Pluto's
like
gonna
that.
crash into every planet and just give them extra moons.
This
I
makes
wonder
me
if
think.
Pluto ever, if it were to like enter a planet's atmosphere, if it were to just become a moon. If
Junior, me
it's,
too.
I don't know how small it is.
I wonder. You'd think it could potentially be a moon or something.
I bet it could be like a moon for like Saturn or Jupiter. They're probably big enough.
Oh
Because I
yeah.
don't know how big Pluto is, because moons can't really circle around planets if they're too big. Because they'll like gather like so much like momentum that they'll just fly out of there.
Oh my god. And the memes for the end.
Earth were to be ending. Imagine how many memes there would be.
There would be too many. Too many. I love memes. The end of the earth in memes. That would make me feel okay
I
about the
think
earth
memes are
ending.
going to be the end of the world.
Oh, that's another debate in itself. Oh. Yeah. Okay, yes. Junior, I get it. We're seriously almost done. We need to talk about getting common denominator today. Sorry.
Yeah.
Little less lesson, more, chit chat. It's all good. Purpose either way. Okay, so of the 8 planets in our solar system, Pluto is now a dwarf planet. 3 are closer to the sun than Mars. What fraction of the planets are closer to the sun than Mars? How would we represent that as a fraction? We got to think part over whole. This is almost a ratio type question. Aiden says 3/8. What do you guys think? Do you guys agree with Aiden? Yeah. I totally agree with Aiden too. Very good. There are 8 total planets. Sorry, Pluto, right? But 3 are closer to the sun than Mars. So that's kind of what they're talking about. That's the part that they're talking about. And the whole are the 8 planets in the solar system. So very good. Yeah. So it's just part over whole. That's what we're representing here with all of this stuff. You are in trouble, guys. Too funny. Okay, remember these little things. This is really important. Okay, right. The sun, heat of the sun. This is so important to remember. Remember, the same number over the same number will give you 1. Okay. A number divided by 1 is just the number. And remember, if you have a a number and you want to turn it into a fraction, we can just stick it over 1. 8 and 8 over 1 are exactly the same thing. Remember, 0 this is the part that confuses people, so make sure you guys make note of this, okay? 0 divided by a number is 0. Okay, so whenever you take the number 0, you divide it by any number. 0 divided by 2 is 0. 0 divided by 3 is 0. 0 divided by 1,000,000 is just 0. 0 divided by anything is 0. But if you put 0 on the bottom, that is undefined. You cannot do that. That's like taking a number, because whenever you divide something or put it in a fraction, remember, it's part over whole.
Yeah, because if you were like to have like 3 cookies and split them between nobody, then the cookies would probably just disappear out of your hands because you're not even doing it to yourself.
Right. Yeah, that's like saying if n is your part and then 0 is your whole, you can't have a part over nothing as a whole. That doesn't make sense. 0 divided by Pluto.
No, I think we just figured out how to make things disappear.
Okay,
Just be like, I'm going to give you to nothing, and then just it disappears out of
0 is
existence.
the black hole. Oh, if we're talking solar system, right?
0 is Pluto. It will destroy everything it sees.
Hey Siri, what is 0 divided by 0?
Oh, not this.
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
That was pretty savage there, Siri. Oh, that's funny. Like, whoa, things just got real with
Jeez,
Siri.
Siri.
Shots fired. Yes, exactly. Oh my gosh. Okay,
I'm Siri, and this is so deep.
we got to talk about this stuff today. We want to find the least common denominator. We want to practice that because eventually, next week, we're going to review adding fractions on subtracting and all that good stuff. A Cookie calling me a name. We asked Siri about what is 0 divided by 0. That's what happened. That was a very good suggestion. That's funny. But okay, we're almost done. Gotta review this stuff super fast. Oh, I said facts because I saw. Okay, so we want to find the least common denominator. So we want to find a common denominator between the two. Okay. Oh yeah, Sam, you're right. I have that. So between 3/7 and 5/14, sometimes you don't have to go too crazy or too complex with it, right? We want to ask ourselves the question 7 and 14. Usually, you kind of stick with the bigger denominator and ask yourself, is there a way to turn this denominator into this denominator? And there is, right? Because, yeah, if we multiply by 2, 7 and 14 are exactly the same. Sometimes it helps to list the factors of it or the multiples. So 7, 14, 21. Sometimes it helps. Okay, Junior, I will post the recording for this part on the Moodle website, okay? Bye, Junior. Yeah, just check Moodle, and this will be right on there to help you with the homework. Thanks for letting us know. I really appreciate it. Yep, beware of Pluto. Thanks. Good luck at your appointment. Boom. I like that. Okay. It's a galaxy now. You guys. Too funny. Okay, so when the numbers are this close together, just like this, okay, 7 and 14, it helps just to list those factors, okay? You got to watch this part. We're almost done. I promise you. I'm not going to torture you with this stuff too much. So we're kind of listing out the factors a little bit. Add another 14. What do you get? 32, right? No, 42. Yeah, 42. So what we can see is we can see that 14 is a common factor between the two, okay? So we don't have to do too much thought into it. 7 and 14 are exactly, they're really close numbers, and we know that if you want to change 7 to 14, all you got to do is multiply by 2. Whatever you do to the bottom, you have to do the top. So we're left with 6/14 and 5/14. So which fraction is bigger, 6/14 or 5/14? Yeah, the 6 is bigger than 5. So we would say 3/7 is a bigger fraction than 5/14 because we got them to have the same denominator, and then 6 is bigger than 5. Yeah, and remember our symbols, the alligator mouth greater than, it always is going to eat the bigger one. The hungry little alligator. Om nom chomp. Yep, that's what it is. Okay, so there's another method that deals with finding common denominators using prime factorization. And I don't think I'm going to use it for this next example because we really don't have to. But we'll use it for the following one. So I'll go back to it. So let's try that with 11/12 and 7/20. So we want to determine which one's bigger. So we want to find a common denominator. So I'm actually, 12 and 20 are pretty close together. So I'm going to start by listing out the factors. Okay. So 12 times 1 is 12. What's 12 times 2? 24. 12 times 3? 36. 12 times 4? 48. Yep. 12 times 5? 60. And I'm going to stop because, you usually go maybe 5, 6, whatever. I'm being sneaky and I'm picking that to stop because I know something from creating these slides. But, you just go a few ways. You don't have to keep going. Now we'll list the factors of 20. 20 times 1 is 20. What's 20 times 2? 40. 20 times 3? 60. So there is our lowest common multiple. Yeah, very good. Remember the tricks for multiplying 20 times anything. You just get rid of that 0 and treat it like 2's. Yeah, very good. Ding, ding, ding. It is 60. So now we have to ask ourselves, we got to change our fractions over to that denominator. So I'll put 20 here for my first one. So 12 times what gets me to, whoop, not 20, 60. Sorry, guys. 12 times what gets us to 60? Yeah, times what you had to, yeah, which is 5, right? So we had to, you're right. You multiply the top by whatever you had to multiply the denominator by. In that case, it's 5. 12 times 5 gets you 60. You got to do the same to the top with 11 times 5. 55, very good. Now we're going to do the same to the other fraction. 20 times what gets us to 60? Times 3. 20 times 3 got us to 60. So we do the same to the top. 7 times 3. What's 7 times 3? Not 35. Try a little bit less. 21. Yeah, that's 7 times 5. That looks like a 5, though, to be fair. It looks like I wrote a 5. Yep. Sorry about that. Yeah, it looks like I wrote a 5 there. And it's really easy to get confused because see how we multiplied the other fraction by 5? That 5 goes with that fraction. Everybody gets confused. So it's easy to get that stuck in your head. So it helps to make a little note of it on the screen or on your paper or whatever. So we got to remember 20 times 5 would get us to 100. So we don't want to do that. So we want to go 20 times 3 because that's how we got to this denominator of 60. So we're going to do the same to the top. 7 times 3 is 21. And then we find out which one's bigger. Sam, that's right. Yeah, which one's bigger, 11/12 or 7/20? Yeah, 55/60 wins, and that was originally which fraction? 11/12. Yeah, I know you meant 12. Yeah, 11/12. So because they might ask you to use the common denominator to figure out which one's bigger. So here we can clearly see which one's bigger, but we got to remember to relate it back to here. So that means 11/12 was bigger. Good. Very good. Last thing I want to talk about, I'm just going to make sure. I think that's our last one there. Oh, there's a lot of denominator practice. Okay, so this method, yeah, it's handy for other ones, right? You're totally right. So this method is helpful if you have 3 fractions. It's kind of a weird method, I'm not going to lie, but I found it really helpful. So the first thing is to write the prime factorization of each denominator. Okay, that's the first thing. That's that thing that we did last week with the different factors, how we broke it down. Then this second step here, this is what the weird step is. For each different prime factor, so out of the 2's, the 3's, whatever, circle the greatest number of times that factor occurs in one factorization. That makes no sense. I will show you what that means. And then we want to multiply all the circled factors, okay? I'll show you what that means. So first thing we're going to do is we're going to do the prime factorization. Sam, you're right. Yeah. We're going to do the prime factorization of all of these factors. So we're going to list it out just like we did before. So we'll start with 15. What are my ways I can multiply two numbers and get 15? Just give me one way. 3 times 5, yeah. And those are both prime already, right? I can't go any further, so I'm kind of done there. Now we're going to do the 18. What can I multiply to get 18? 9 and 2, right. And which one of those can I break down a little further? The 9, yeah. What would I multiply to get 9? 3 and 3, good. Very good. What about 54? What times what is 54? 9 and 6, that's right. This will be our last example. Yeah, very good. We would keep it going a little bit. 9 and 9 goes to 3 and 3. I don't know why I said 9 and 9. And then 6 goes to 3 and 2. And then we're done there. So now let's kind of list our factors. 15 had 3 times 5. 18, and we'll kind of list it in order here, had 2 times 3 times 3. And then 54 had 2 times 3 times 3 times 3. So now what we're going to do is we're going to circle the greatest number of times each one occurs. Okay? So for this one, for 15, the greatest factor is 5, and it occurs one time. For 18, the greatest factor are these two 3s. Now here's what I'm going to double check really quickly. I have it pulled up on the textbook, and this method is weird for me that I'm like, I got to double check something. I just thought of a question. Let's go back so you can see my reference here. Okay, okay. I was confused because the 2 repeats itself. But you see down here, guys, how the, oh, that was faded. I was like, why is that on there now? Get off of there. Okay. See how 54 has the greater number of 3s? So that one we're going to circle for 3s. And then 18 needs one. It can't be the 3s because that was for the 54. So I'm going to circle the 1, 2. So you got to pick a factorization from each one. You just pick the greatest one that occurs. And now what we're going to do is we're going to multiply all those numbers together. 5 times 2 times 3 times 3 times 3. And that, to me, is a really good calculator thing just to throw in there. So we're going to throw it in our calculator, unless you guys can do it before me. Let's see. Let's do it. Let's see here. I'm going to go to Desmos. Desmos. Okay, we're going to go 5. Oh, 270. I think that's what it is. Yeah, very good. Times 2 times 3 times 3 times 3. 270. That is our common denominator. Oh, I will have to try that next time, Mr. Aiden. That's pretty cool. Isaiah's trying it there. You can see it. That's cool. Pretty cool. Okay, so that method's a little different, okay? So what I'm going to do is I'm going to continue the video. Okay, friends, here is where I'm going to continue and show another example of that, just in case it did not make sense for you. So this one, we're going to find the least common denominator of 3 different denominators. So I'm going to do what we did before, and I'm going to do that prime factorization. So 20 splits into 5 and 4, and then 4 splits up a little further to 2 and 2. So we would say that 20 can be factored into 2, 2, and 5. Oops, I shouldn't put a comma there. That should be a multiplication symbol. Okay, then let's do it with 24. That splits into 4 and 6. And then it splits a little further into 2 and 2 and 2 and 3. So 24 splits up to 2 times 2 times 2 times 3. And then 45 splits up into 9 and 5. And again, you don't have to pick 9 and 5. You don't have to pick 4 and 6. You could have started with 12 and 2 and gone that way. It works the same way. You should get the same end result. So 9 splits up further into 3 and 3. So 45 splits up into 3, 3, and 5. Now I just want to pick the highest representation for each one, for each set of factors, okay? So there's 2 2's here, but here there's 3 2's. So I'm going to circle the 3 2's because that is the highest representation of factors. Here there's 1 3, but in 45 land here there's 3 3's. Okay? And I haven't yet selected anything for the 20, and you have to select something for the 20. So for that one, since we've already picked 2's, you would pick the 5. We would not pick the 5 in the 45 area just because you've already chosen the 3's there. So every number should have a circle. So then we're going to multiply them. We're going to multiply 3 times 3 times 2 times 2 times 2 times 5. 3 times 3 is 9. 9 times 2 is 18. 18 times 2, yeah, I'm not going to play around with this. I'm going to use my handy dandy calculator. 3 times 3 times 2 times 2 times 2 times 5. 360. That is your least common denominator. Very good. Very, very good. Okay, let's try this next one here. Nope, not that one. This one. Okay, so this one's kind of the same deal. Only we're not really going to have to maybe prime factor it because, you know, they're pretty standard. They make sense there. So this one, we're going to list them out. So the factors of 5, there's only 5, right? 1 and 5. Factors of x would just be x, right? X times x times 1, maybe, but 1 really we don't have to put. And then x to the third, you would list x 3 times. Okay? So here we're going to, this one's a little bit different because we have x and then 3 x's. We would only use those 3 x's. And then we're not going to really circle anything there because we've already chosen x's. In our other example, we had different numbers available in that line. I think I can hit undo. Hold on. Undo, 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 undo. Oh my gosh, this is taking forever. There we go. So here we had other number available in this line. Okay, we've already chosen the 2s and we've already chosen the 3s, but we haven't chosen a 5. So that made us choose a 5 for 20. I guess it really wouldn't have mattered if we circled it up here or here because 5 is the same. So you have 1 5, 3 2s, and 2 3s. That's why we chose it that way. But in this example, you have 5, you have x, and then you have 3 different x's. We just kind of choose a representation of each group. So for the x group, you would circle the 3 x's. And for the 5 group, you would circle the 5. So here your common denominator would be 5, and then x times x times x. Remember, when you're multiplying terms that have the same base, you add those exponents. So we would have 5x to the 3rd because there are 3 x's there. That is your common denominator. I feel like we should do another example, but I don't have any more. So again, remember for this one, you're listing out all of the, you do the prime factorization, and then you choose the highest number in each factored group. Okay, maybe I can get another example. Up there. No, that's not what I meant to click on. There it is. Okay. So, like for 11 and y, it would be 11y you would choose. Okay, so let's see. Yeah, let's say you're going to do the lowest common denominator between 3/12 and 3/15. Let's do. So let's say you're going to do it between 3/12 and 4/15. So we're going to deal with the 12 and the 15. So 12 we can write out. You can do 4 and 3. And that 4 reduces to 2 and 2. And then 15 goes to 3 and 5. So then we'll list our factors. Factors of 12 are 2 times 2 times 3. And factors of 15 are 3 and 5. Now what you have to circle and then multiply is one representation for each group. So out of the 3 group, the 2 group, there's only one option here. It's these 2. So that's what you circle. Out of the 3 group, you can see, you would choose which one's bigger. So if there were like 3 3s here or 2 3s up top, then you would circle this. But there's only 1 3 in each one. So you just circle one of them. You don't need both, just one. And then there's only 1 5. So that's what you would multiply together. 2 times 2 times 3 times 5. And that will tell you the least common denominator, which is, let's see, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 6. Cool. Okay, the rest of this involves writing equivalent fractions. So you just have to ask yourself, how do you go from 4 to 20? What do you multiply by? 4 times 5 is 20. So then you have to do the same to the top. 3 times 5 is 15. So whatever you do to the top, you do to the, the bottom, you do the top. If there's an x there, don't let it fool you. It just goes along for the ride. So 11 times 4 is 44. So you do the same to the top. 9x times 4. And 9x times 4 gives you 36x. So that x just goes along for the ride. Okay, and remember, if you have a whole number, 3 is the same as 3 over 1. And 1 to get to 7, you're going to multiply by 7. You do the same to the top. You get 21 over 7. And that's it, my friends. That's all I got. Thank you for coming. Thank you for going back and watching this video if that is what you did. And yeah, I will see you next week. Have a lovely week. Bye, guys.